Students, let us start chemical equations in this video. Let us first look at a chemical reaction. In the activity 2, a colorless solution of zinc sulfate is formed on addition of zinc dust to the blue solution of copper sulfate. This chemical reaction can be written as in brief as follows. I have shown you this in video clip also. So, when you take copper sulfate solution, that is copper sulfate solution is blue in color. Okay, now you're going to add zinc to it. So when you add zinc to copper sulfate solution, the blue color copper sulfate solution turns colorless due to because it gets converted into zinc sulfate and copper is that is copper is produced. Now see this chemical reaction, how you are going to write. See, aqueous solution of copper sulfate. Okay, see, aqueous solution of copper sulfate plus zinc dust, okay, will form, see, this are the reactants. So it's going to form which product? Aqueous solution of zinc sulfate, okay, plus copper. Copper is deposited on the zinc metal, isn't it? So this simple way of representing a chemical reaction, okay, in words is called a word equation. So you have written the chemical reaction in the form of words, isn't it? So these are the words you have written. So writing the equation that is representing the chemical reaction, okay, in this way we call it as word equation. So a word equation can be written in a further condensed form by using chemical formulae as follows. So copper sulfate, now see, aqueous solution of copper sulfate, right? So that can be written as CuSO4 plus this zinc dust, okay, it is written as Zn, will form ZnSO4, that is zinc sulfate plus copper. So the representation of a chemical reaction in a condensed form, this is condensed form, isn't it? Yes, you saw above it was in a detailed, you had written it in words, long form. Now this has become a short, right? It has become short, and this we call it as condensed form using chemical formulae is called as the chemical equation. So how you are going to represent the chemical reaction? You are going to represent it in a condensed form. Okay, yes, you are representing it in a condensed form using what? Chemical formulas, isn't it? So this we call it as chemical equation. Now in the above equation, copper sulfate and zinc are the reactants. They react with each other to form copper particles and a solution of the colorless zinc sulfate as the products having totally different properties. The ionic bond in the reaction copper sulfate breaks and the ionic bond in the product zinc sulfate is formed during the reaction. Now see, let me explain this to you. So see what happens. Now first of all, let me tell you this, the left side, okay, the left side substances we call it as reactants. So this copper sulfate and zinc are the reactants, and to the right hand side we are going to write the products. Okay, so how many reactants are there in this reaction? Yes, CuSO4 plus zinc, isn't it? So two reactants, they are going to combine with each other to form zinc sulfate and copper. Now during the chemical reaction, what is going to happen is the bond, the ionic bond which is there between this copper and sulfate, okay, that is going to break. Yes, it's going to break, and the ionic bond between zinc and sulfate is going to form. Okay, so copper sulfate will form zinc sulfate. So see, now this zinc sulfate, it is colorless, and copper sulfate was blue in color. Now this zinc sulfate which is there, it is having totally different properties when you compare it with copper sulfate. That is when you are going to compare it with the reactant. So the products are having entirely different property than the reactant. So the ionic bond between copper and sulfate is going to break in the reactant, and in the product the ionic bond between zinc and sulfate is going to form. Now writing a chemical reaction equation. So how you are going to write a chemical equation? Let us now see the conventions followed while writing a chemical equation. In a chemical equation, the reactants are written on the left hand side while the products on the right hand side. Now see, we are going to see some of the rules, some of the conventions, okay, which has to be followed while writing the chemical equation. Now see, first convention, what is this first convention? The reactants are written on the left hand side while the products are written on the right hand side. An arrow heading towards the product is drawn in between them. This arrow indicates the direction of the reaction. So see, you can see here now the copper sulfate and zinc. Okay, this is the arrow. So copper sulfate and zinc, these are the reactants. These reactants are written to the left hand side and the products are written to the right hand side of the arrow. Now this arrow which is there, okay, it is going to tell us the that is, it is going to tell us which side the reaction is taking place. So an arrow heading towards the product is drawn in between them. So the arrow is going to tell you the direction of the reaction. Now the second one, if the reactants or products are two or more, they are linked with the plus sign in between them. For example, in the equation 2, a plus sign is drawn in between the reactants copper sulfate and zinc. Similarly, a plus sign is drawn in between the products zinc sulfate and copper. Now see, remember, okay, if the reactants, okay, if the reactants are more than one, see, if the reactants are more than one, here you can see there are two reactants, isn't it? So what you're going to write, you're going to write a plus sign, okay, in between the reactants and the products also, okay. If they are more than one, then you are going to write plus sign between them. So see, to make the chemical equation more informative, the physical states of the reactants are indicated in the equation. Their gaseous, liquid and solid states are indicated by writing the letters G, L and S respectively in the brackets. Moreover, if the product is gaseous, instead of G, it can be indicated by an arrow pointing upwards. If the product formed is insoluble solid in the form of precipitate, then instead of yes, it can be indicated by an arrow downwards, that is pointing downwards. So when reactants and products are in the form of solution, okay, in water, they are said to be present in aqueous solution state. This state is indicated by putting the letters aqueous in brackets after their formulae. Now see the equation which is there, okay, you can make it more informative also. Now till now you saw how to write a simple chemical equation. Now you know, see, you can make it more informative. How you that is how you can make it more informative. Now for example, you know, if it is liquid, okay, if water is there in it, if it is a solution, then you can write as AQ, okay. Yes, AQ means what? It is aqueous. And if it is in the solid form, then you're going to write it as yes, okay. You're going to write it as yes. Now If, see here also, zinc sulfate, AQ is written in the bracket. That means what? The zinc sulfate is in the aqueous form. So copper is in the solid form. Now, if it is a gas, okay, then it's written as G in the bracket. But, okay, instead of writing G in the bracket, you can just show this with an upward arrow also. So, you can write gaseous in that way also. Now see, one more thing, okay, if it is a precipitate, means if you are finding a substance which is insoluble, it is an insoluble form, that means what? It is in the precipitate form, isn't it? So then you are going to indicate it, okay, you are going to indicate it with an downward arrow. So see, when heat, okay, is this clear to you now? See, copper sulfate, if it is aqueous, AQ. If it is solid, you are going to denote it with yes. Let me tell you once again. See, if it is a solid, you are going to denote it with yes. If it is aqueous, AQ. Then if it is that is, if gas is liberated, you are going to denote it with upward arrow, okay, and if it is precipitate, you are going to denote it with downward arrow. Hope this is clear to you. Okay, now see, fourth one, when heat is to be given from outside to bring about a reaction, it is indicated by the sign delta, that is in the triangle form, written above the arrow, that indicates the direction of the reaction. For example, the reaction in which slaked lime is formed on heating limestone is written as follows. Now see, here you can see the slaked lime has been formed, okay. Yes, now the reaction, okay, is shown, the direction of the reaction is shown with an arrow, and this calcium carbonate which is there, okay, this is heated. Now the heat supplied, okay, is shown with this sign. Now see, this formula is very important. This is limestone, okay. Let me show it to you. See, this is limestone, CaCO3, okay. Yes, CaCO3, that is calcium carbonate, is also called as limestone. You should know this. And slaked lime is calcium oxide, okay. Yes. So remember, slaked lime is calcium oxide and limestone is calcium carbonate. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as follows. Now see, in the upper reaction, okay, in reaction 4, you have seen you are going to supply heat, right? Yes, so this, okay, it is indicated by this triangle or delta on the arrow. Now if it is, that is, if heat is liberated during the reaction, okay, here you are supplying heat in this case, right, but here heat is liberated during the reaction, that time, okay, you are going to write in the product plus heat. That means what? During the reaction heat is liberated, okay. Now next one, it is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reactions, okay. So sometimes you will have to fulfill certain conditions. That means what? You will need certain temperature, certain specific temperature is needed for the reaction to take place. See, certain specific temperature is required for the reaction to take place. You require certain pressure, you might require a catalyst also to bring about some reactions. You know, specific temperature means what? You might, that means required to supply heat to, that is to maintain specific temperature for the reaction to take place, or you might, that is you might require to supply pressure, or you might require an catalyst also. Now what is this catalyst? You know, catalyst is a substance which is going to fasten the reaction or speeden up the reaction without itself taking part in the reaction. Means what? This catalyst which is there, this is not going to take part in the reaction, but what it is going to do, in its presence the reaction is going to take place very fast, or it might speeden up the reaction. Now these conditions which are there, they are indicated below or above the arrow indicating the direction of the reaction. For example, the reaction of a vegetable oil takes place at the temperature of 60 degrees Celsius with hydrogen gas in presence of the nickel catalyst, and is written as follows. Now see, this vegetable oil, the reaction between the vegetable oil, okay, yes, see, let me show it to you. The reaction between vegetable oil. Now you can see in this reaction, this vegetable oil, okay, it's in the form of liquid. L is given to you in the bracket, isn't it? That means what? Vegetable oil is in the form of liquid. This hydrogen is in the form of gas. Okay. Now above the arrow 60 degrees Celsius is written. Means what? You will have to supply temperature, that means you will have to maintain temperature during the reaction of 60 degree Celsius, and you will have to use catalyst, nickel catalyst. So during, in the presence of this nickel catalyst, okay, it is going to form vanaspati ghee. So this chemical reaction is going to take place at the temperature of 60 degrees Celsius and in presence of nickel catalyst. So this nickel catalyst, you know, it's not going to take part in the reaction, okay, but it is going to speeden up the reaction. Now see, next one, that is sixth one, special information or names of reactants products are written below their formulae. For example, copper on reaction with concentrated nitric acid gives reddish colored poisonous nitrogen dioxide gas. Now see this reaction 7. Okay, this copper, you know, it is in the form of solid. Okay, it's reacting with this nitric acid which is in the form of aqueous state. Okay, in what state it is? Liquid state, aqueous state. How is the acid? It is concentrated. Okay, it's not dilute, it is strong acid. Strong acid means what? Concentrated nitric acid. So it is written below this reactant. Okay, so what type it is? It's written below. Then copper night, it's going to form, okay, the product formed when copper reacts with concentrated nitric acid. So which product you're going to get? You're going to get copper nitrate. Okay, now this copper nitrate which has been formed, okay, it is aqueous in state, okay, plus nitrogen dioxide gas is formed. Okay, G, see, G is telling you that it is in the form of gas. NO2 is what? Nitrogen. N is nitrogen. O2, di. Okay, di means what? Two atoms of oxygen, right? So nitrogen dioxide plus water. Okay, H2O is water. It's in the form of liquid state. It's in the liquid state. L is written over there. Yes, it's telling you. However, on reaction with dilute nitric acid, the product formed is nitric oxide gas. Okay, so when it reacts, so when it's reacting with concentrated nitric acid, that time nitrogen dioxide gas is formed. Other products are same. Okay, and see, when this copper is reacting with dilute nitric acid. See, you can see what type of nitric acid, it's written below it, that is dilute, right? So when copper reacts with dilute nitric acid, that time, okay, copper nitrate plus see nitric oxide, here nitrogen dioxide, dioxide NO2, okay. So nitrogen dioxide was formed in first case, right? Yes, nitrogen dioxide was formed when it reacted with nitrate with concentrated nitric acid. But when copper reacts with dilute nitric acid, that time simple only nitric oxide is formed. And this nitric oxide, okay, it's in the form of gas. You can see G written over there. That means what? It is in the gaseous form. And water, you can see it's in the liquid form. Now see, next try this apparatus, okay. You require test tube, conical flask, balance, etc. So what all you require here? Apparatus, you require a test tube, conical flask, and balance you require, okay. Now chemicals you require is sodium chloride and silver nitrate. Now see, procedure: take sodium chloride solution in a conical flask and silver nitrate solution in a test tube. So what you are going to do? In a conical flask, you are going to take sodium chloride, NaCl, salt. Yes, you know the common salt which we eat at home, okay, that is sodium chloride, NaCl, okay. Now you are going to add some water in it, so it will become sodium chloride solution. You are going to take it in the conical flask. And in test tube, what you are going to take? You are going to take silver nitrate solution. Now tie a thread to the test tube and insert it carefully into the conical flask. So what you are going to do? You are going to tie a thread, okay, to the test tube, and you are going to insert it into the conical flask. Make the conical flask airtight by fitting a rubber cork. Weigh the conical flask with the help of a balance. Okay, I have shown you, I think, before this in the activity. Okay, yes. So what you are going to do? In the conical flask, you are going to take sodium chloride. In the test tube, you are going to take silver nitrate solution. Okay, and that is what you are going to do. This test tube which is there, okay, you are going to insert it inside this conical flask, and you are going to make the conical flask airtight by fitting a rubber cork. Then weigh the conical flask with the help of balance. See, you can see here. See, wait, let me show it to you. See, this is the conical flask, okay. You can see here, this is the conical flask, okay. In the conical flask, you have taken sodium chloride solution, okay. And in the test tube, this is the test tube. In this test tube, you have taken silver nitrate solution, okay. You are going to tie a thread to this test tube, okay, and you are going to insert it in this conical flask. Yes, then you are going to close this conical flask. You are going to make it airtight. And what you are going to do? You are going to weigh this conical flask with the help of a balance. Okay, you can see here. See, you are weighing it in the balance. It's showing 300.23 grams. Yes, 23 grams. Now see, weigh the conical flask with the help of a balance. Now tilt the conical flask and mix the solution present in the test tube with the solution in the conical flask. Weigh the conical flask again. Now see what you are going to do. You are going to tilt the test tube. See, just like this. Okay. That means what? The silver nitrate solution which is there in the test tube, okay, is going to enter this sodium chloride solution, and the reaction will take place, okay, between them. So the reaction will take place between them, between silver nitrate and sodium chloride. Yes, then see what you are going to do. You are going to, okay, insert the empty test tube in the conical flask, and again you are going to weigh it. Now reaction has taken place, you can see, between the silver nitrate solution in the test tube and the sodium chloride solution, okay. So you can see the solution has become colorless over here, right? Yes, so this that is silver chloride AgCl has been formed, plus silver plus sodium nitrate solution has been formed. Now this silver nitrate, okay, sorry, the silver chloride which has been formed, it is in the form of precipitate. You can see here, precipitate means what? It has settled in this conical flask below, okay, and the solution which is there at the top, it is sodium nitrate solution, NaNO3 solution, okay, sodium nitrate solution, and the precipitate which has been formed below, that is silver chloride AgCl. You can see the downward arrow means what? It is in the form of precipitate. It is white color which has settled down. I'll show you the reaction, okay. I'll show you the reaction, but before that, see, let me tell you, even that is after the reaction, the weight, the mass of that is going to remain same, okay. Yes, that is the clip which I am going to show you. I'll just show you the reaction between sodium nitrate and silver, silver nitrate solution and sodium chloride. I'll just show you the reaction between them, but I will, in this clip I am not showing you that the weight is maintained in both the cases. That will not be shown to you in this clip, but I just want to show you the precipitate which has been formed, okay, the silver chloride precipitate. I want to show it to you. See, sodium chloride solution, okay, has been taken in one of the beaker. See, sodium chloride solution has been taken in this, and silver nitrate has been taken in this beaker. Yes. Now just see, you are mixing it well, okay. Sodium chloride salt in water, okay. You are mixing it well so that the salt will dissolve properly in it, and till it dissolves, you are going to shake it. Silver nitrate also, you are going to shake it properly so that it dissolves completely. So you can see the sodium chloride solution, it's transparent. Silver nitrate a little whitish in color. Now you can add either sodium chloride to silver nitrate or silver nitrate to sodium chloride. Any ways you can do, okay. Yes, see, he's adding sodium chloride to silver nitrate solution. Now you can see curdy white color formation, isn't it? Just like how the milk spoils. When milk spoils, you can see now how it collects together, just like that, okay. When you are adding sodium chloride to silver nitrate, same thing happens. See, you can observe. You can see the curdy white formation. Now you are going to keep it for some time. See, silver nitrate, okay, yes, you can see here silver nitrate plus sodium chloride, okay. So AgCl and NaNO3 has been formed. So silver over here, okay, silver. Now see, this silver is replaced by, you can see silver is replaced by which one? Yes, silver nitrate, sodium, correct. Yes, silver is replaced by sodium and sodium is replaced by silver over here. So it forms, silver nitrate forms sodium nitrate in the product, okay, and sodium chloride forms silver chloride. Okay, now let me continue this. So this is double displacement reaction, because you can see, and see this white precipitate which has been formed, that is silver chloride, okay, silver chloride, and sodium nitrate is the upper solution. Wait, let me show it to you. See this upper solution, okay, yes, and the precipitate you can see over here down which has settled. You can see the precipitate below. Yes, white color precipitate.